So this is a quick introduction to a proof of concept that I've been working on called FaaS-netes, and it is a Kubernetes plugin for functions as a service. Now FaaS is a serverless framework which you can use with a regular Docker engine. It has built-in first-class support for Docker Swarm. You can use YAML files to define your functions, and they build out to Docker images. We then have a built-in UI that lets you test your functions, and we already have over 2,300 GitHub stars, and that keeps rising. Now this is really about adding Kubernetes support, so I'm going to show you exactly what I've been able to achieve and how that works. So FaaS-netes is really an activity to port across to Kubernetes from Docker Swarm. Now this repository actually has a bit of a microservice in it, and that's going to be used in tandem with the existing FaaS code to let us create functions and run them on a Kubernetes cluster. So I've got a couple of pictures here. The first one is showing you really how things work in Docker Swarm. We have an API gateway exposed on port 8080, which is actually exposed on your network or the internet, and we have two functions. /function node info is a route that will proxy off to any number of replicas of your function in Docker Swarm. So as you call this, you'll get a kind of round robin effect. First time you'll get node info.1, 2, and etc. And with Docker Swarm, this is called a service, and each of these replicas is called a task. We also have functions, we also have routes like system/functions, which is a get, and that goes over to the Swarm API and lists any services matching the FaaS label. We then get some kind of JSON back, which has the function name, the amount of replicas, and how many times it's been called. So when you look at Kubernetes, there's a bit more work to do here. In fact, there's quite a bit more work. Instead of going straight to the API gateway, we need to use an ingress controller like Nginx or maybe even Traffic. That will call into the API gateway using the same routes that we saw before, but now we need to proxy that over to FaaS-netes, which will also run on port 8080, and all of this would be within your Kubernetes cluster. So when you call a function such as node info, how we'll actually address that is over DNS by using a service and a deployment together, and that will also have a label. So when you call that function, we can just simply go to the service DNS alias, which in this case nodeinfo.default will work. That will look up the list of pods and it will call through to one of those. Also means that your service has an IP address that won't be changing. The get functions endpoint again will do something similar to what it did with Docker Swarm, but here we're going to look up the list of deployments where the label is a FaaS function, and it will either contain the value of true or maybe the name of the function. That lets us then go ahead and create that JSON response that we saw earlier. So we have the proxying, we have the get function, and the next logical step is the create function. So right now you can create those through kubectl with config or command line operations, but when that is implemented in FaaS-netes, what will happen is we will first create you a deployment and then a service. And those are what we will use to provide this endpoint on the FaaS-netes daemon. So what I'll show you now is the two terminals here on my Mac. I'm using Minikube. There's some instructions for setting this up. And I exposed the FaaS-netes service on port 8080. That's gone through to this port on the local machine from the virtual machine. So first of all, I'm going to have a look and see what functions are available. As you can see, we're not seeing anything. So if we typed in kubectl get deployment, we see a similar story. There's just FaaS-netes there. Now we can deploy new functions using the same syntax that we would have used on Docker Swarm. So if we have a look at the test drive instructions available on GitHub, I can see here a function that was put together by a contributor called Ed, and this gives you a kind of quote of the day. And what we want to do is send over the curl to the same address. So this is port 31986 rather than 8080. System function, so it's all the same. And we're even using the same JSON format here. Now, as soon as I hit enter, we're going to see a service and a deployment get created. From this point, I don't need to know the cluster IP of that oblique service. All I really need to know is how to get to FaaS-netes D, which we already have on that high port that's been mapped. Now that might be controlled by an ingress controller like, as I said before, Nginx or Traffic. So let's go ahead and try it out. Now, this function doesn't take any commands. We can just send the curl straight into it with no additional data. And it gives you some quite random quotes. So we've got one function deployed, one replica of that function. It's now got an age as well. Let's create a second function. So now I'm going to suggest we'll try the node info. Which is available through functions namespace. What that will do is when we hit it, it will tell us the host name and a bunch of other information. This may or may not be ready. It looks like it's ready. Okay, and we've got that one replica there. We can also pass in some data here, like the string verbose, and it will print out a bit more information for us. Now, in the Docker Swarm version of this, we also have Prometheus in the stack monitoring the usage, and we'll do something similar for Kubernetes. But at the moment, I can go ahead and check my deployments. I actually have one for node info there, and I can just scale that up. Let's have 3 replicas. Now, over on the right hand side, we've got the terminal again, and we should be able to go and curl that and get back each of the replicas one in turn. And there you can see the host name is varying, and we've now seen 3 of those replicas. And so really we're providing a very similar interface to what you have with existing FaaS as if you deployed it on Docker Swarm. You don't really know the difference. So it'd be great to get some feedback on this from Kubernetes community and from FaaS users. And if you want to contribute to the code, more than welcome. There's still quite a bit to do. So there's 4 instructions in the GitHub repository. Here we're using Minikube. It tells you everything you need to do to get started and to try this out. But it'd also be great to see this running through a Linux cluster with kubeadm, for instance. So thanks for watching, and looking forward to hearing from you on GitHub.